Hi there, this is Teen STEAM at the Clarington Public Library. My name's Amy and we are talking about electricity today. I'm going to show you how to create an electric capacitor, also known as a Leyden jar or a Clarington bottle. So, STEAM, if you didn't know, is an acronym for Science, Technology, Engineering, Art, and Math. So in our experiments today, we are going to be dealing with science and engineering because we're creating our bottles or jars. I received this idea from a shocking article that the Clarington Museums and Archives posted from the Canadian Statesman. And it's a 17th century way of creating a Leyden jar or an electric capacitor out of a person. So definitely some dangers. So I thought I'd do some research at the library and see exactly what could happen with this experiment. And this is what I found out.
The Leyden jar, sometimes called a Clarington bottle, was a breakthrough in the history of electricity. It was invented in 1746 at the University of Leyden in the Netherlands. The device was very simple, but was the first to create an electric charge. Discovered independently by Dutch physicist Peter van Missenbroek of the University of Leyden and German inventor E.G. von Kleist, it was the first means of creating and storing electricity that an experimenter could discharge on their own. You might be thinking of the famous use of the Leyden jar in Benjamin Franklin's kite experiment performed in 1752, where he wanted to use a conductive rod to attract lightning to the Leyden jar, which gave rise to the phrase, "capture lightning in a bottle." He realized how dangerous this experiment was, so instead of using conductive rods, he used a wet string attached to a kite instead. Franklin stood in a shed to keep the silk string of the kite dry to insulate him while the hemp string attached to the kite got wet to provide conductivity. A house key was then attached to the hemp string and connected to a Leyden jar, and a silk string was attached to this. The kite wasn't hit by visible lightning, but Franklin did notice that loose threads of the string repelled each other and realized that the Leyden jar had a charge. When he moved his hand by the key, there was an electric spark. Using the Leyden jar, Franklin proved the electric properties of lightning.
All right, so getting to the materials for our experiment today. So since we are doing two types of experiments, there's two sets of materials that you'll need. So I'm going to kind of split them up. We'll start with the newspaper one first. That way you can decide which materials you'll need. So for the newspaper experiment, the very first one we're going to try, you're going to need two 2x4 pieces of wood. And that's going to lay across 4 glasses, mason jars I have here, or these are kind of like spice jars. So I actually use 2 different heights because once you put one down, it kind of heightens the second one when you place it. So I do have 2 taller ones and 2 shorter ones. So just keep that in mind when you're setting up your set. For the newspaper experiment, you also need a rubber comb. The rubber comb I actually got at Shoppers Drug Mart, and the modern day version of rubber I found is latex, something to look for when you're going through the ingredients on a website, or you can ask someone at the store. But I found that, a set of 2 at Shoppers. I got a piece of silk at Fabricland. I just asked them and it's 100% silk so that it's a little bit closer to what they had requested in the newspaper ad that we use. So that's all you need for the newspaper experiment that we start with. And then onward, if you wanted to create your very own Leyden jar, you will first need a jar. I used a glass kind of jar that I found. You can use plastic water bottle, about the 750 milliliters or a 1 liter, whatever you want to use. Just make sure you take all the plastic off of it. Make sure that the lid is not metal. So we found that you definitely want the nail that we use to be the only metal so that the kind of electric circuit will work. So we used the cork lid that came with this, but the plastic lid from a water bottle will work just fine. Also need that nail that's going to go through. I chose a fairly large one so that it would go about halfway or a quarter of the way down, especially if you're using a shorter chain, so whatever you want to use or have. And then I actually just used an old necklace for the chain. You can go to a hardware store and get an actual chain that matches, that can go right on the nail that you use. But I used the necklace chain and then I just kind of looped the clasp so it made a little hole. It's a little bit trickier. It took a few times to get it to wrap around and stay. But you want something that's a little bit longer than the jar so that it sits in the bottom of the tin foil, so it'll complete that circuit. Finally, we use the aluminum foil to wrap our Leyden jar, and to create the friction, I used plastic boat paddle. So I took the paddle end off, and it's just a plastic tube, so you could use like a mop handle, anything that's plastic to use to hold. And then I actually used paper towel, just a piece that I ripped off that you wrap around. It also suggested to use a wool sock, which I did do in the early experimentation stage, which kind of worked. I found that the paper towel worked a little bit better though, so definitely something that you can try and experiment with using paper towel and wool and see which one is better. So those are all the materials that we're using today, but there's definitely variations out there that you can use if you know what a conductor is and what insulator is, which we'll talk about later. So let's get to the experiment and try these out. So what's happening during the Leyden jar experiment? The Leyden jar is a collection of electric conductors with one insulator that is used as a roadblock to trap the static charges inside, making it a storage unit of sorts for an electric charge. When we created friction using the plastic rod and the paper towel, this caused electrons from the paper towel to flow to the plastic rod to create negative and positive static charges. When those charges come in close contact to the nail, the electrons jump to the conductor, down the nail, down the chain, around the tinfoil, and stops at the glass jar, since it's not a conductor, but an insulator, and the charges get trapped and start to accumulate inside. Polarization occurs during this process, causing negative charges inside and positive charges on the outside of the tinfoil. So when you go to release the charge to get a shock or see the spark, you must be in contact with both at the same time, one hand holding the tinfoil and the other hand using the finger to release the charge. So now, moving to the newspaper experiment, my hypothesis is that the human assistant, played by me, was one big conductor, and the glass jars down at the bottom underneath the wood act as the insulators that stops the charge. So after I use friction, brushing the hair on the top of my head to create positive and negative charges, since my hand was buffered by the silk, when I place the comb close to my hand, it jumps, kind of like the nail. Then, when another conductor or person comes close to my hand, the charge will jump back as a shock or spark, releasing the stored charge. So I have included a bibliography of my research so you can have kind of a starting point to research more about this fun and interesting STEAM experiment. There are a lot of great resources found at the library and through our e-resources for further research needs, so you can find those even at home. If you attempt the experiment, have your own hypothesis, or want to share your ideas with us, use our hashtag and tag us at Clarington Public Library and hashtag keep calm and steam on.